Hello everybody, welcome again to the ETABS and SAFE course. Now in this lecture we will begin with the foundation design. We have said before that when we want to design the foundation, we want to export the base story to the SAFE. So we go to File, Export Story as SAFE v12. We select here base and we select this option, export floor loads and loads from above. Okay, we select the dead load and live load only. Then we click OK and OK. We press here OK and we go to File, Import, Save. So now we have importing the loads to the SAFE. First of all, we go to Set Display option. We deselect this invisible and we press OK. Now we show this point. This point represents the loads. Here, for example, we had a column, so this point represents the loads that are from the top, the story 16 of this column to the story 1. The sum of loads that the columns bear from story 16 to story 1. For example, if we select this point or any point of this point, we press right click, we press here to loads. We showed here that we have, and the gravity Z, we have a dead load from above equal to 4,323 and live load equal 1,013. Now civil engineer, when he begins to design foundation, he begins with isolated foundation. Let's first of all show together what are the type of the foundation. First of all, we have isolated foundation. It is a one foundation for one columns. We have combined foundation. It's one foundation for two columns. We have a strip foundation. It's one foundation for a wall, a continuous wall, or a 3 columns or more. And finally, we have mat foundation for all the columns on the plan of the project. So now we will begin with the isolated foundation. So we return to the SAFE. First of all, we want to check the materials. So we go to Define Materials. We need a foundation F'(C) equal to 30. So we name this F'(C) equal to 30. So here is right 30. We move, we edit here only, we put gamma equal 25 and we press OK. And we need a tensile stress of reinforcement equal to 420. So 420 and 420 times 1.25. Then we press OK. So we have defined the material F'(C) and T420. Now we want to determine the thickness of the foundation. The thickness of the foundation is equal approximate to 0.1 times n, where n is the number of stories. Here in this project we have 16 stories, so the thickness of the foundation equal to approximate 1.6 meter. But we will try with a thickness, we will assume that this thickness equal to 1.3 and we will check it after. So we want to define this foundation. We go this isolated foundation for this column, for example. So we go to define. So we go to define slab and we press here modify. First of all, we name it isolated foundation, and the type we change from slab to footings. Here, as we said, we put 1,300 and we will show after if we want to increase or decrease the thickness of this isolated foundation. Then we press OK, then OK. Okay, now we want to know what is the bearing capacity of the soil to determine dimension of this for isolated foundation and X and Y, the dimension of an X or an Y. So we want to return to the presentation for and we have a QA equal to 3 kilogram per centimeter square, the bearing capacity of soil. we return to safe. Now from it we can calculate the dimensions of this isolated foundation. So we press here on this point and right click. We have dead load equal to 4323 and dead live load equal 1013. We go to the calculator and we put 4323 plus 1013 and we sum dead load plus live load, and we divide this load on the bearing capacity of soil, which equal to 300 kilonewton per meter square. So we have get 17 meter square. This is the area of the foundation. So if we need to have a foundation we need a foundation with area equal to 17 or 18 meter per second. Now we will go to this option, quick draw area around points, and we want to draw this foundation. So we put here slab, okay, slab and rectangular slab, which we select here the isolated foundation that we have defined. Now we want to put the dimensions of this isolated foundation. If we have the area equal to 18, so let's put the direction and the dimension of the foundation and y direction equal to 6. So the dimension and x direction equal to 3. So we put here 6 and here we put 3. Then we want to check it after. So we draw this isolated foundation here, and also we want to draw the columns. So we go to define slab. We want to put here add copy of property. We name it at columns or stuff. We name it at stuff. Let's name it stuff, and we put here stuff. Okay, the stuff, the thickness of the stuff equal the thickness of the foundation. This stuff represent the part of the column included in this foundation. So the stuff is the part of the column included in the foundation. So the thickness of the stuff equal to the thickness of the foundation. We press here OK, and then we return to the same option or comment, and we put here the dimension of the columns, which equal to 0.4 by 1.6, and we withdraw this part of column which called stuff. So now we had draw the columns and the stuff. So now we want to tell safe that this foundation is existing on a soil with bearing capacity equal to 300 kilonewton per meter square. So we select this foundation and we go to define support data soil properties. We modify this soil one, and we put here 300 times 1000 300 times 120. We multiply always the bearing capacity with 120. This is a constant to define the soil. So we press here OK, then OK, and we have this green point that represent that we have defined the bearing capacity of soil. Now we can begin to run the program. We save isolated. So now save again with run. When save finish, so we go to show. First of all, we want to show the punching shear of this foundation. When the punching shear of this foundation is safe, so the thickness of this foundation is sufficient. Okay, so we press here on the show punching shear design. We show that we have a number below 1, so we have a safe punching shear. We are safe in punching shear design, so the thickness of the foundation is sufficient. Now we want to show if the dimensions of this foundation is sufficient. We go first of all we go to define load combination, we add a new combination. We want to check, we put here dead load 1 and live load 1, we name it at service. Okay, and we do run. So now we want to show if the sections of this foundation is sufficient, dimension of this foundation is sufficient. We go to display, show reaction forces, and we go to soil pressure with the foundation surface, and we press apply. We have a bearing capacity equal to 300 kilonewton per meter square. Now we show that we have a pressure on the foundation equal to 345. So we need to increase the dimension of the foundation to be safe. So we unlock the model and we go to select this foundation, and we go to edit area, expand. We want to increase the area of 20 centimeter equal to 200 millimeter, and we press OK from all sides. Then we press run. Now we will recheck the soil pressure. We go to show reaction forces, and we press apply. Now we have 295 below 300, so we are safe. So now we have checked the thickness and the dimension of the foundation, which are now sufficient. Now we will go to design and show the reinforcement of this foundation. First of all, we want to show what are the dimensions of this foundation. Now we draw the dimensions lines, and now we want to draw the strip designs like the waffle slab and design slab. So here we begin with A. So from here to here we want to put the middle of 64, so we put here 3.2, 3.2, 3.2 and 3.2, and we draw from here to here. Now for B direction we put 1.2, sorry 1.7, 1.7, 1.7, 1.7, and we draw from here to here. Now we can begin the run, and we can go to display, show slab design, strip, and we put here impose minimum. As usual we put here, let's put 16. Okay, layer A, we press apply. We show that on layer A the reinforcement and the X direction and the X direction we need 74 bars of diameter equal to 16 and X direction. Now we want to show the layer B. We need here from here to here, from here to here 39, and from here to here 39, and here we have from here to here we need approximate 55 or 58 diameters, 50 bars of diameter equal to 16 from here to here. And we note that we don't need an isolated foundation, a top reinforcement, only we need bottom reinforcement. Thank you for listening. We will continue with the other type of foundation in the next lectures.